Welcome to the VulDB e-learning session, Introduction to the Cyber Threat Intelligence Platform Possibilities. Please take a seat and enjoy what you are about to learn. As usual, you will have the possibility to try things yourself. If you want to engage as such, please keep your VulDB account data ready. And now, let's get started. In this session you will learn how to use the web interface of the CTI platform, which indicators are available, how to do extended analysis, what possibilities are available to extract useful information, and how to incorporate such in your security processes. The VulDB CTI platform helps you to understand the structure, goal, behavior, and activities by actors. An early understanding of such makes it possible to anticipate such, to be prepared as good as possible, or to support forensic analysis after an incident has happened. We provide a rather unique collection of data and analysis capabilities. First, there are known indicators like IP addresses and host names. This is a rather traditional set of information you might have used in another context before. Second, we have established a very unique monitoring of Internet and Darknet activities regarding security-relevant behavior. This includes websites, social media, forums, and underground marketplaces. We are interested in actors discussing technologies, products, vulnerabilities, and exploits. Third, the incorporation of geopolitical information to determine relationships between single actors, groups, regions, and countries. Alliances or tensions have an impact of goals, targets, and methodologies. All this information is correlated and analyzed. Big data, machine learning, and artificial intelligence helps to interconnect information, identify interesting data points, and generate dedicated forecasts. This makes it possible for our customers to get access to a wide variety of cyber threat intelligence information. Indicators include IP addresses, host names, actors, campaigns, vulnerabilities, tactics, techniques and procedures, weaknesses and attack patterns. We distinguish between verified indicators which were associated with offensive activities. But we do also provide unique predictive indicators. These are forecasted by our platform. We do not recommend using them to filter access attempts. But they are highly useful in a very early attack detection. Additional heat maps alert when there is an increased number of activities and interest targeting specific vulnerabilities, vendors, products, countries, and sectors. And the event alerting helps to identify emerging activities, who is involved, where this is going to happen, when the incident is expected, and why it is going to happen. Now let's take a look how to use the web service of VulDB. Some of the extended cyber threat intelligence features are available to unauthenticated visitors or users with a free account. But the most helpful insights are limited for customers with a subscription plan or customers with additional CTI possibilities unlocked. Now is a good time to log into your VulDB account to experience the following demonstrations yourself. On the front page you will get access to some of the cyber threat intelligence capabilities. To make things easier, we will call them CTI from now on. The threat intelligence box shows 5 entries which have the highest interest score at the moment. These vulnerabilities are discussed, researched, or even exploited the most. Scores range from 0 to 10, whereas 10 is the highest level. All scores above 8.0 declare important issues which will be exploited soon or are exploited already. Therefore, our real-time scores are very good indicators for emerging or established attack trends. On the right-hand side, you will find a diagram which groups the interest score by product types. Popular product types are operating system, web browser, and content management system. You will see the progress of interest for the last few days. This is a verified indicator. But you are also able to see our prediction for tomorrow. This is based on historical data, current events, and the machine learning capabilities of our platform. It helps you to anticipate which product types will be approached in the near future. Below is a global heat map. You will see this map in different views on the web service. Countries with a high level of activities become dark red. Reduced activity is indicated by light red. And if there is not enough data available, the countries are colored with light gray. You can hover over countries with your mouse to see additional details like the country name, current activity score, and the associated threat level. Country activity scores range from 0 to 1000 and are populated in real time as well. If you access a vulnerability entry, you will see different scoring information in the header: CVSS score, current exploit price, and the CTI interest score. These help you to understand the risk relationship of a vulnerability very quickly. We will now discuss them in detail to give you a head start about vulnerability risk scoring. If you scroll down, you will find the detailed CVSS data in the according sections. CVSS stands for Common Vulnerability Scoring System, which is an industry standard to calculate risks of vulnerabilities based on their characteristics. Version 2 was used for many years, but most companies switched to version 3 as it provides better representation of vulnerability details. Scores range from 0 to 10, whereas higher scores stand for more severe vulnerabilities. The base score incorporates the static characteristics of a vulnerability like access vector and privilege requirements. They do not change over time. Contrary to the temp score, which includes temporal effects like the availability of exploits or countermeasures. These change within the lifecycle of a security vulnerability. We provide our own CVSS data, but do also support external sources like NVD, CNAs, vendors, and researchers. Our unique meta score evens the scores by different sources to provide an overall score. Further down there is the EPSS score. This stands for Exploit Prediction Scoring System, and is an open, data-driven metric to estimate the likelihood that a vulnerability will be exploited. Scores range between 0 and 1, and higher values indicate higher probabilities. EPSS scores might be a useful factor within standardized risk calculation and CTI predictions. But they are rather static and not as flexible as our CTI interest and activity scores. Right below you will find details about exploit prices. High prices indicate an increased desire for exploits. The 0-day price is the one that we calculated for the time before a vulnerability gets disclosed. This is like the starting price of a vulnerability. After the disclosure of a vulnerability, the so-called today price becomes relevant. This price usually decreases due to events like the availability of technical details, alternative exploits, or countermeasures. But this price will also decrease over time because vulnerabilities tend to lose their popularity. Let's go back to the top of the entry page. You will find a button called CTI. By clicking on this element, you will get access to CTI details for this specific vulnerability. If you show the CTI report for a vulnerability entry, you will get access to a wide variety of real-time information. The level of details and the number of items depends on your VulDB subscription plan. On top is a quick summary that explains the structure of the vulnerability. It's the same data that you would see on the regular vulnerability entry or the RSS feed, for example. Right below are the IOB, indicator of behavior. This section shows the behavioral aspects of actors interested in and working with this vulnerability. You will see a timeline of activities which helps you to determine if the activities are increasing or decreasing over time. Additionally, there will be charts illustrating which languages and which country of origin we were able to associate within actor communications. This is helpful to understand the geopolitical context and exposure. And a list of identified actors is available. It is possible to click listed items to start a drill down of the available information. The activity map highlights the countries which show the most activities. Dark red indicates high and light red indicates low activities. Hovering over a country with your mouse allows you to show additional details like country name, activity score, and threat level. Now follow different indicators. These are only shown if such are known. If the sections are missing, there are no indicators yet available. However, this might change within seconds as collected data is gathered and analyzed in real time. The first section shows IOC, the so-called indicators of compromise. These consist of IP addresses or IP ranges, actor names, and campaign names and help to identify attack attempts or successful compromises. Clicking on the items provides additional drill-down information. An indicator is either validated or predictive. Validated means that the item was collected as part of real activities. They may be used to detect ongoing attacks and block them. Predictive indicators are generated by our artificial intelligence system. We assume that these indicators will become relevant soon. As they are not validated, it is not recommended to use them for automated blocking. Instead, they shall be used for an early attack detection within logging, monitoring, and alerting mechanisms. Predictive indicators make it possible to anticipate attacks before they are successful, and the associated indicators would become validated. And then there is the confidence level for an indicator. Possible values are low, medium, and high. Indicators declared as low and medium are best suited for attack detection. And indicators with a high confidence might be used for automated filtering. The next section is TTP, which stands for Tactics, Techniques, and Procedures. The framework by MITRE helps to understand the preferred approach by certain actors and within specific attack scenarios. We list the technique and subtechnique, the weakness identifier CWE, and the access vector. As within IOC, every entry is either verified or predictive. And the confidence level is either low, medium, or high. Now we talk about IOA, the indicator of attack. These list potential fragments used for technical activities like reconnaissance, exploitation, privilege escalation, and exfiltration. We associate IOA to different classes like files, libraries, arguments, input values, patterns, and network ports. Especially network-based mechanisms like firewalls, web proxies, and intrusion detection systems may profit from these indicators. As of now, you are familiar with the general CTI views and details, therefore you can handle the view for vendors, products, product types, countries, actors, and IP addresses as well. Here you see the overview of all associated actors we are monitoring. There are hundreds of APT groups that we are tracking for years. By clicking one of them, you are able to see the specific details. There is a lot to discover. All CTI-related views work very similar but originate from a different starting point. Which one you prefer depends on your requirements. Incorporating CTI as part of a traditional vulnerability management usually prioritizes the view of a specific vulnerability, vendor, product, or product type. If extended geopolitical context is relevant, then actor or country views might be preferred. All of them conclude their views with a list of references. These external sources discuss the data points and might be consulted to gain a deeper understanding of actors, activities, behavior, and intentions. It is also possible to do a custom analysis for vulnerability entries, products, technologies, and time frames. Open the view by clicking Threat and Analysis in the main menu. Then enter your data into the form and wait until your individual report is generated. Now that you understand the different views and indicators, we shall discuss the analysis of CTI data. This diagram shows the CTI activity score development over time. We will see that certain patterns help to understand the life cycle and recognize trends of a vulnerability. Ideally, an early detection helps to anticipate emerging threats to be one step ahead of the attackers. Popular vulnerabilities tend to start with an increased level of activity. For them, it will take a few days until a steady low level is reached again. Ideally, the growing interest is visible a few days or at least hours before. For example, after approximately 2 hours, it already becomes obvious which vulnerabilities of a Microsoft Patch Tuesday will draw the most offensive attention. Like CVE 2022-37696, which affects Microsoft Windows and was disclosed in September 2022. Some vulnerabilities are sleepers. This means they stay at a low level for days, weeks, or even months. And then suddenly a spike arises, which is usually happening when an exploit gets published. This was happening with CVE 2022-41352 affecting Zimber Collaboration Suite. Immediately, multiple actors become interested in the vulnerability, exploitation possibilities, and available countermeasures. These might be the most dangerous class of vulnerabilities because they can get their victims by surprise. And if a vulnerability immediately spikes at the beginning and drops to a low after 24 or 48 hours, it is a good indicator that it was overhyped by media. This does not mean that the vulnerability is not important. But it is not as important as sources claim it to be. Therefore, other vulnerabilities might require more attention. A good example is CVE 2022-40684, which discussed a remote vulnerability in Fortinet products. We may discuss an example how we were able to predict exploitation of F5 products very early. The whole case and timeline is public. So, you may verify that the events happened as explained by reviewing the sources mentioned. On May 6, 2022, our CTI platform was able to determine some increased activities targeting F5 products. At this moment it was unclear which products or vulnerabilities might be in focus. Just 6 hours later things became clear for our CTI team. We were able to identify strong exploit research activities towards the product Big IP. It was possible to associate CVE 2022-28705 with these activities. Another 14 hours later it was furthermore possible to see the same emerging activities regarding CVE 2022-1388. It was clear that these weaknesses will be attacked very soon. On May 9, 2022, this is 3 days later, the alerting on our CTI platform peaked for CVE 2022-1388. We could determine first exploit approaches and informed our customers about the imminent threat. Our team was able to identify 27 IP address ranges and APT actors associated with these exploiting activities. To understand how early our attack threat detection was, you may look at the CISA exploit announcement AA22-138A. Exactly 9 days later, on May 18, 2022, they have added CVE 2022-1388 to their catalog of exploited vulnerabilities. This is rather late and misses the threat of CVE 2022-28705 as well. Therefore, our customers were able to identify the emerging activities a total of 12 days earlier. It is important for us that customers can easily access and work with our data. This is the reason why we provide a simple and efficient API. Access to this API happens via a public web endpoint. Your personal API key must be present in the data part of the post request. Together with the API request type, additional parameters, and optional filters. The response will contain a collection of the requested items and associated details. The default format for the response is JSON, but we do also support other formats like XML and CSV. Now let's discuss some examples of the API. On the left-hand side, you will see the code for a request. We will show the plain HTTP post data. Every parameter consists of a key and value pair which is associated with an equal sign. And all parameters are concatenated with an ampersand. Your preferred tool or programming language might use a slightly different syntax to create HTTP post requests. Our public GitHub repository provides a few examples for some popular languages like PHP, Python, and PowerShell. On the right-hand side, we will print a simplified output of the response data. The default JSON format will be used as it is simple and well-structured. Basically, we distinguish between the Vulnerability API and the CTI API. They work very similar but support different request types and data points. The Vulnerability API makes it possible to request vulnerability details. But these might also contain optional CTI information. In this simple example we request the vulnerability details for the VulDB entry with the ID 67685. By setting the field Details to 1 we enable all vulnerability details. And by also setting the value CTI to 1 we will get all available cyber threat intelligence information associated with this entry. This is necessary to have access to this specific data as it is not part of a regular vulnerability API request without this parameter. In the response you will find a lot of information about the vulnerability. At the bottom of the output, you will find the CTI fields. You are familiar with the data as the same is provided on the website as well. Here you see the current activity score of the entry. The current score of 0.10 is rather low and just regular noise. Nothing special that requires immediate attention. Below are the top countries that we associate with offensive activities right now. In this case Spain, Switzerland, and USA. You might also find a list of associated actors, indicators like IOA and TTP which is not shown in this example. All requests of the Vulnerability API might enable the CTI features to add the associated fields. But to do specific CTI requests, you must use the CTI API instead. This happens on the same endpoint but requires other request types and provides different response details. Commercial users are able to use the CTI API if enough API credits are available. Enterprise customers need to purchase access to the CTI capabilities of the API to use the request types we are now about to discuss. If this did not happen, you will receive the API status code 402, which stands for Payment Required. All requests to the CTI API also support the parameter details, which is 0 by default. If you define 1, you will get additional details about the requested object. Therefore, the behavior is the same as in the Vulnerability API. In this example, you can request CTI information for a specific IP address. To do this, you have to use the request type, a pattern, and define the IP address you would like to look up. You will always get a response with all the data that we have associated with the IP address or IP address range. The amount of the available data might vary depending on the possibilities of our big data analysis. In the response, you will find basic details about the requested IP address. This includes host names, timestamps of first recording, and confirmation. The risk rating ranges from 0 to 10 and shows how dangerous we think this source might be. There is also an attribution to known APT groups if possible and an association with source countries. Then follows a list of vulnerabilities which might be discussed, researched, or approached otherwise by this IP address or linked actors. Below you will find a list of all indicators of attack that might be associated with the IP address. The same category structure is used as seen on the website. We distinguish between files, libraries, arguments, values, patterns, and network ports. This list will include predictive indicators. Therefore, we do not encourage you to use them for automated filtering and blocking. Instead, they shall be used for an early attack detection during logging, monitoring, and alerting. Further below there are all associated tactics, techniques, and procedures according to the MITRE attack framework listed. Such information is very helpful for bug hunting and forensic analysis. Be aware that this is predictive information as well, which helps you to be one step ahead of the attackers. You have seen how to request CTI information for a vulnerability by ID, and how to get CTI information for an IP address. The same request-response structure is used for information about actors. If you know the name of an actor, you may request the associated information via API. There are also some additional request types which are able to collect CTI information and statistical relationships. On the web service, we provide a view which shows a top list of the vulnerabilities with the highest level of identified interest. The very same list can be requested via API by using the request type, Activities Top. This request type expects a number of items to be shown. These will be listed in the response in descending order of the interest score. This is ideal to keep you informed about emerging and established threats. Please consult our online knowledge base for more information about the API and the CTI capabilities. All request types, response structures, data fields, and possibilities are well documented and explained with simple examples. In this course you have seen how to use the web interface of VulDB, which indicators are available and how they are gathered, which possibilities for analysis and extraction are available, and how to process the data to improve your vulnerability and threat management. This is it. Thank you very much for taking the time to take this course. We hope that you had the chance to learn something about cyber threat intelligence and our CTI platform. There are a lot of details and possibilities to discover. Our data and developer teams keep adding new features on a regular basis. If you are an enterprise customer and have any questions, please contact your key account manager to discuss the possibilities for a workshop. Users with a free license may contact our support team via email or the contact form on the website. We are happy to help you establish a professional vulnerability and threat management. We wish you all the best, stay safe and secure.